An introduction to RGBs. How RGB technology is changing decorative light applications. Presented by Minleon International, your provider of cutting-edge LED products. Table of contents. Points to clarify. RGB Basics. RGB Microchip. RGB Controllers. RGB Software. RGB Wiring. Data and Power Boosters. A power calculation, and questions and resources. RGB Points to clarify. RGBs have been in the marketplace for years. The critical difference is the present ability to maximize their core functionality at a reasonable cost. To date, this ability has been limited to larger venues given RGB design complexity and high cost. RGB Basics. RGB lights are a type of LED, often characterized as LEDs on steroids within the industry. RGB stands for red, green, and blue. Each RGB light, also known as a node or pixel, consists of 3 LED light channels, one red, one green, and one blue. So if you have a 25 RGB light string, the string consists of 75 channels. This is important if you desire to use light design software. Some providers define their software solutions in terms of channels, not lights. One RGB channel equals 256 levels of intensity, given the industry standard 8-bit RGB chip. The red RGB channel relays 256 color levels, ranging from 0% color intensity or brightness to 100%. The green and blue channels relay the same intensity levels as the red. By employing components typical in an RGB lighting system, each 3-channel RGB light can be color blended with one another to create a limitless array of colors and effects. The components are a microchip, a controller, light design software, and data communication wiring. The microchip. Each RGB light embodiment includes a microchip that receives software instructions from the light controller through the data line. When you buy a 25 RGB light set, you're buying 25 individual microchips. This is one reason RGB bulbs cost more than traditional LED bulbs. The positive offset is the added value. Each bulb will morph into an array of colors and an unlimited number of effects. The light controller. A light controller is needed to operate an RGB light. A light controller is a device, including a microprocessor, that runs the software required to operate the RGB lights, similar to how a computer runs its software programs. The controller directs more than just a string of lights. It controls each individual light of each individual string, or RGB tube, bar, tape, etc., within a light design. The software. RGB software is specifically designed to operate RGB lights. As the software is executed, the light controller interprets its instructions and directs the microchip in each light to change color and effect. The wiring. An RGB light string typically consists of 3 or 4 wires. Minleon RGB light strings are designed with the cost efficiency of 3 wires. One for positive current, one for negative current, and one for transmitting the software data. Data and power boosters. RGB light designers must account for data and power requirements within a larger RGB light design. The solution is properly placed data boosters, sender-receiver cards, and power supplies. Such accessories are needed to enhance the software's data signals and power through the wiring over longer distances. RGB power calculation. Minleon's RGBs run on 12-volt DC power. Most Minleon RGBs use 0.03 amps. To account for resistance down the wire, we recommend reserving 0.035 amps per RGB. Note, the distance between RGBs must be taken into account, especially bulb spacing over 12 inches. Custom designs such as these should be tested and troubleshot prior to installation. Questions? Please email reggie@minleonusa.com and reference this presentation. We encourage you to view these related tutorials: product line overview, sales and marketing guides, and the accessories guide. Thank you for your interest in Minleon RGBs.